So good evening, welcome to Sakala Vidya educational channel. So welcome to AP DSC School Assistant Mathematics classes, JEE mains level classes. So we have been discussing matrices chapter. In the previous session we have completed 15 problems. So today we shall continue from 16 problems onwards. Okay, let us start our session. Welcome to Venkateshwarlu. Right, welcome. Right, let us start 16th question. Question number 16. If A equals to 1 2 1 -1 0 3 1 2 minus 1, then the trace of A. So what is the trace of matrix A? Trace of A is, okay, option A is 0, B, option B is 2, option C is 3, option D is 4. So what is the right option? Nani Babu, Murga, welcome. Okay, trace of A. A is equal to matrix is given, then we need to find out trace of A. See, my dear students, trace of A can be written as shortly trace of A is equal to sum of the diagonal elements. Sum of the diagonal elements of a square matrix. Sum of the diagonal elements. So sum of the diagonal elements means, so this is the diagonal. So this is the diagonal. The sum of all the elements in this diagonal we need to find out. 1 plus 0 plus of minus 1. So you get 1 minus 1, obviously 0. So answer is 0. A is the right option. A is the right option. Sushma, so good afternoon. Good afternoon. Yes, Venkateshwarlu, absolutely correct. So let us move to 17th question. 17th question. Right. 17th question. If A equals to 1 0 0 1 0 0 0 1 1 0 minus 2 4 and identity matrix of third order I is equal to 1 0 0 0 1 0 0 0 1, right, and A inverse is equals to 1 by 6th of A square plus CA plus DI, then the value of C plus D is, the value of C plus D is, okay, option A minus 5, option B 11, option C is minus 6, option 4 D is 5. So which is the right option? It's very interesting question this is. So A is equal to 1 0 0 0 1 1 0 minus 2 4 is given, and this is the identity matrix. A inverse is given that 1 by 6th of A square plus CA, C is constant, plus DI, then the value of C plus D we need to find out. So what are the values of C plus D? Can you solve this problem? Okay, let us move to next page. In next page I will explain the super shortcut for this one. super shortcut. Super shortcut means, so first let us take A matrix, that is, what is the A matrix given, that is 1 0 0 0 1 1 0 minus 2 4. So first all of you find out trace of A first. Trace of A. Already in the previous problem, 15th problem, we have discussed how to find out trace of A. So sum of the principal diagonal elements, 1 plus 1 plus 4. So that is 6. Okay, next to find out actually cofactor, sum of the cofactors of principal diagonal. So that means, my dear students, actually the cofactor of 1, this sign is plus minus plus. So that means actually deleting this row, this column, 4 plus 2 6 plus cofactor of this one, deleting this row, this column, 4 minus, so deleting this row, this column, 4 minus 0 4 plus 4 plus cofactor of 4. Cofactor of 4 means determinant of 1 0 0 1, that will be 1. So this is 11. After that, determinant of the matrix find out, det A find out. Det A is equal to, so expand by row 1. So that means 1 into determinant of this matrix. So what do you get? 4 minus of minus plus 2, 6. So now write down characteristic equation. Or it may be called as corresponding equation. Characteristic equation is given by, this is very important step, given by, see, I will give the formula, shortcut formula, A square minus of trace of A, this is A cube, A cube, trace of A into A square plus sum of cofactors of principal diagonal elements of A minus det A of I equals to 0. So this is called actually characteristic equation. This is very, very important, even gate examination or CSIR net examination. This is very, very important. So now the, my dear students, now the characteristic equation, see, I will write in green color. A cube, trace is 6, so minus 6A square you can write. Sum of the cofactors of principal diagonal is 11, that is 11A. So minus det A is equal to 6, I equals to 0. Okay. So now actually what is given, A inverse we need to find out. With the help of this one we need to find out A inverse. So how to find out the A inverse means, see, this we can write now. So multiply with A inverse. See, with A inverse, then what do we get? A inverse of A into A square, write down, no problem. A square into A cube only, minus 6 times A inverse A of A, write down, plus 11 into A of A inverse, write down, minus 6 I into A inverse is equal to G, null matrix into A inverse is null matrix only. So my dear students, remember, A inverse of A is equal to identity matrix I. So that means this is I A square, means you get A square, I into A, so this will be 6A plus 11I. So I into, next A into I is equal to A, or I into A is also A. This is A inverse. So minus 6 A inverse is equal to O. So then my dear students, you see, this can be written now. So this can be written. See. So now the 6A inverse is equal to, we can write as a square minus 6a plus 11i. So A inverse is equal to 1 by 6th of, you can write a square minus 6a plus 11i. What is given? Just compare. So given that A inverse is equal to here 1 by 6th of a square, clear, a square plus ca plus di. So comparing to this one, you get c value and d value. C is equal to minus 6, d value is equal to 11. So what we are asked? C plus d we are asked. So that is equal to 11 minus 6. So our answer is 5. This is a very beautiful question. So good evening Sumalata. Yes, not minus 5, plus 5 is the right answer. Plus 5 is the right answer. Go back. You are asked C plus D. C plus D. So that means 5 is the right answer. 5 is the right answer. So my dear students, actually you remember one thing. So this super shortcut we need to remember. Super shortcut. So this super shortcut, if you remember, very simple manner we can do it. Otherwise you need to find out a square value and next a cube value. It takes very lengthy. So this is the super shortcut. Please follow this method. Right. So 17th question completed. Now let us move to the 18th question now. Are you ready? 18th question. So 18th question here, right, if A is equal to, if A equals to 2 minus 2 minus 4, right, minus 1 3 4, 1 minus 2 minus 3, then A is okay, option A, nilpotent matrix, nilpotent matrix, nilpotent matrix. Option B is orthogonal matrix, orthogonal matrix. So option C is idempotent matrix, idempotent matrix, idempotent matrix. So D is involutory matrix, involutory matrix, involutory matrix. Okay, I will give the concept of nilpotent matrix, idempotent matrix, orthogonal matrix and involutory matrix. So first let us discuss the concept. See, for example, A is a square matrix, A square, so A to the power of n equals to O, then A is called nilpotent. This is called nilpotent. So nilpotent matrix. For example, A square is equal to A, then A is idempotent. Idempotent. So this is the test. For example, A square is equal to I, that is involutory matrix, involutory matrix. A into A transpose is equal to I, then orthogonal, A said to be orthogonal. So clear now? So better these concepts you need to remember. Now A to the power of n is equal to null matrix, then A is called a nilpotent matrix of order of index n, that is called. So A square is equal to A, then it is called, A is said to be idempotent. A square is equal to I, that is called involutory. A into symmetric matrix, it's A transpose, that means transpose of a matrix, is equal to I, then it is called orthogonal matrix. So that means actually here we need to check all these three cases. Nilpotent matrix means whether it may be A square is equal to O or A cube is equal to O, then A is said to be nilpotent. A square is equal to A square is equal to I, or A into A transpose. That means better you check A square value. But instead of checking A square, directly we can write characteristic equation. So characteristic equation, now I am going to write shortcut, super shortcut. What is the super shortcut? A cube minus trace of A. Trace of A means 3 cancel 2. This will be 2A square plus next what we need to write? Sum of the cofactors of the principal diagonal elements. So that means actually 2 cofactor. So deleting this row, this column, minus 9 minus is here C, minus 9 plus 8 minus 1. Next cofactor of 3, deleting this row, this column. So that means deleting this row, this column, minus 3 into minus 6 and next plus 4. This will be minus 2. Next cofactor of minus 3, deleting this row, this column, 6 minus 2 plus 4 and minus the determinant of this matrix. What is the determinant of this matrix? You see, so determinant of this matrix means you can write like this, 2 into det A, write down. So det A is equal to 2 multiplied by, so minus 9 minus 9 plus 8, so minus 1. So this is actually is actually minus sign, minus of minus plus 2 only, 2 into deleting this row, this column, plus 3 minus 4 minus 1, right, minus 4 into, okay, deleting this row, this column, plus 2 minus 3 minus 1. So that means actually you have here, so minus 2 plus 4. So determinant will be 0. So this is actually you will be getting 0 into I is equal to null matrix. So then what do we get now here? So here you see A cube minus 2A square. So this will be 4 minus 3, 1, A equal to O. So this we can write A cube minus A square minus A square plus A equals to 0. Let us take here A square common. If you take A square common, what do you get now here? A minus I, because in matrix algebra instead of 1 we need to write I. So take here minus I common. So we get A square minus, so this is A square plus A. So take A square common or I common. So A square minus, this will be, sorry, this is 0 itself only, A, yes, A cube minus 2A square, A cube minus A square. 1 minute, we need to interchange them, we need to interchange. 1 minute, let me complete. So this we can write A cube minus A square and minus A square plus A equals to O, null matrix. So here A square common, we have A cube A minus I. So here actually you can take minus A common out, you get A minus I equal to O. So then what do we get? See here you get now, so very interesting. So what do we get means here, okay, A square minus A multiplied with A minus I equals to 0. So here you get two cases, A square is equal to A and A is equal to I, but you check this one, A square is equal to A. If A square is equal to A, that is the idempotent matrix. So C is the right option. 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 So what about other? Tomorrow onwards actually I will wind up the session because nobody is watching. Why should I take the risk? Right. 18th question. Next let us move to, so now 19th question. So 19th question. Right. Next question, see, if A equals to 1, 2, 5, 2, 4, 10, minus 1, minus 2, minus 5. Okay, this is the matrix. Then A is option A, nilpotent matrix, nilpotent matrix, nilpotent matrix. B, idempotent matrix, idempotent matrix, idempotent matrix. C, symmetric matrix, symmetric matrix. Okay, option D, involutory matrix, involutory matrix. Simple, with the help of characteristic equation everything we can find out. So first to find out characteristic matrix. So if you are able to prove that A square is equal to A, that is idempotent, A square is equal to O or A cube is equal to O, nilpotent matrix, A transpose is equal to A transpose is equal to A cannot be happen, it is not symmetric. If A square is equal to I, then we can say that involutory matrix. C has been eliminated. So only out of A, B, D we need to select one of the options, right option. So first let us apply the super shortcut here. So before applying the super shortcut, first write down trace of A, first trace of A write down. So trace of A means sum of the principal diagonal elements. So 1 plus 4 minus 5, obviously 0. So next let us say sum, yes, yes means sum of the cofactors of principal diagonal elements, principal diagonal elements. One by one let us do separately. So deleting this row, this column, minus 20, so minus 20, this is plus 20, 0, plus next deleting this row, this column, minus 5 plus 5, 0, and actually cofactor of minus 5, 4 minus 4, 0, this is also 0. Trace A 0, sum of the elements, cofactors of principal diagonal elements also 0. Next det A find out. So det A equals to, actually if you take minus common out, so minus common out, you get 1, 2, 5, 2, 4, 10, 1, 2, 5. So that means if you take out minus common from R3, here these two rows are identical. So det me also 0. So now the characteristic equation becomes A cube minus, see, A cube minus trace A, that also GO. Next sum of the cofactors into A, O is equal to O. So A cube is equal to O. A cube is equal to O means actually here A is a nilpotent matrix of index 3. So A is the right option. A is the right option. This is the beautiful shortcut, instead of doing all these finding A square value, A cube value, better you can directly will get it. A cube is equal to O, so that we can say that is actually here nilpotent matrix of index 3. Okay, 20th. My dear students, I will give you, try this question. So I will check, we will give the answer. If A equals to minus 5, minus 8, 0, 3, 5, 0, 1, 2 minus 1, 1, 2 minus 1, then A is okay. So A, idempotent matrix, idempotent matrix. B, nilpotent matrix, See, orthogonal matrix, orthogonal matrix, orthogonal matrix D, that is actually involutory matrix, involutory matrix. Already have given the concept of idempotent, nilpotent, involutory matrix as well as orthogonal matrix. So first try to find out characteristic equation, that is also called actually here corresponding equation to the given matrix we need to find out. So my dear students, first of all find trace A, trace of A. Trace of A means sum of the principal diagonal elements. Minus 5 plus 5 cancel, minus 1. Next S find out. S means sum of the principal diagonal elements or sum of the elements of principal diagonal. So that is equal to actually cofactor of 5. Deleting this row, this column, minus 5, 0. So minus 5. So cofactor of this one, this element. So this element deleting this row and this column, plus 5. So this is plus 5. And next minus 1 cofactor, minus 25 and plus 24, that will be minus 1. So clearly you can write minus 1. So sum of the elements of sum of the cofactors, sorry, I will write once again because I have written wrong. This is sum of the one minute, I will write it. Sum of the cofactors of principal diagonal. So that is equal to minus 5 deleting this row, this column, plus 5. So minus 25 plus 24, minus 1. So obviously you get minus 1. So next determinant of the matrix we need to find out. That is very important. Det A. So determinant of the matrix means actually the more number of zeros is consisting of third column. So expand by actually here expand by C1 column 1. So minus 1 into this one. So minus 1 into determinant of this matrix, that is equal to minus 25 plus 24. So that will be actually you get minus of minus 1 plus 1. So now the characteristic equation. This is a shortcut. Characteristic equation is given by is a cube minus, I will write for the sake of late viewers, trace of A into A square plus S. S means sum of the cofactors of principal diagonal into A minus determinant of A into I equal to 0. So this is the characteristic equation for 3 by 3 matrix. For 3 by 3 matrix. For 2 by 2 also we can define. So now substituting the respective values, see now I will take the other color, green color, A cube. So trace is minus 1, minus of minus plus, that we can write A square. So S is minus 1 minus A. So this is 1, I equals to 0, right. Okay, let us take from these two, let us take A square common. You have, if you take A square common, A minus I you will be getting. From these two, I common, A common, say A square minus I, A cube minus A common, A square minus I. So from this one take I common, you get A square minus I. So you will be getting A square minus I is common. So A square is equal to I. If A square is equal to I, then A is called involutory matrix. Involutory matrix. So D is the right option. So D is the right option. D is the right option. Yes. Okay. Just go through it. So A square is here actually factors you get A square minus I into A square plus I is equal to 0. A square is equal to I and A square is equal to minus I. For A square is equal to minus I, we don't have any particular name. So since A square is equal to I, then A is said to be involutory matrix. I hope it's very clear to you. So 21st question. 21st question. Next 21st question here. So let us move to one more question actually here before going to this one now. If A equals to cos theta, right, minus sin theta, next cos theta, next again cos theta. Okay. So question number 21, sorry. If A equals to right cos theta minus sin theta, next sin theta and cos theta. So then A is option A, nilpotent matrix, B, idempotent matrix, C, orthogonal matrix, D is actually here what do you write, involutory matrix. Right. So can you solve this question? Okay, can you solve this question? Here A is equal to cos theta minus sin theta and cos theta, then A, nilpotent matrix, idempotent matrix, orthogonal matrix, involutory matrix. So very simple technique you follow here. Just like for example, consider first row as a one vector, second row as a other vector. Find dot product. If the dot product is 0, then we can say that orthogonal. So for example, first row you consider as a first vector, say A bar is equal to cos theta I minus sin theta j. This is a super shortcut. So B, you can say this is sin theta I plus cos theta j. Find A dot B. So what is A dot B? A dot B is equal to, so product of the I components plus product of the j components. This is we can write cos theta sin theta and minus cos theta sin theta. So both gets cancelled, you get 0. So therefore A is orthogonal matrix. This is a super shortcut. A is orthogonal matrix. So C is the right option. So whenever trigonometric is there, orthogonal, you need to test any two rows or any two columns, treat them as a vector, find out dot product. If the dot product is 0, then that is obviously definitely it becomes orthogonal matrix. Otherwise you need to check A into A transpose is equal to I, that also we will do it. Wait, second method is matrix method. Second method is matrix method. I explained super shortcut method. So for example, here A is equal to, what is the matrix given here? Cos theta minus sin theta, and sin theta and cos theta. Clear? Now find A transpose. A transpose means actually interchanging rows into columns. The matrix obtained by interchanging rows and columns is called transpose of A. So this we can write cos theta minus sin theta, right? It becomes sin theta and cos theta, right? Let us find out A into A transpose. A into A transpose. So cos theta minus sin theta, next sin theta and cos theta, right? So multiplied with, so cos theta sin theta minus sin theta and cos theta. So what is the matrix multiplication? So matrix multiplication is row by column method. Row by column. Row by column the multiplication is. So that means first row first column. What do you get now here? So cos theta minus sin theta into cos theta minus sin theta. Cos theta into cos theta, cos square theta, minus sin theta into minus sin theta plus sin square theta. Clear? Now first row second column. So cos theta sin theta and minus sin theta cos theta. So minus cos theta sin theta. Second row first column, that is sin theta cos theta. So plus cos theta into minus sin theta. So minus sin theta cos theta. So next second row second column, that is sin square theta plus cos square theta. Sin square theta plus cos square theta is the identity. So this one gets cancelled, this one gets cancelled. So we have the beautiful result 1 0 0 1. This is nothing but I. So therefore A is orthogonal. This is intermediate method, lengthy method, but I explained, see, the very simple method. Very simple method. So both the methods I have done. As you wish you can apply. Clear? Right. Okay. 22nd problem. So let us move to the 22nd problem. 22nd problem. Right. If A equals to 1 0 1 2, then A to the power of 4 equals to A to the power of 4 equals to A, option A, 254i minus 255a, option B, 254i plus 255a, C, option C, 255a minus 254a, sorry, I, option D, this is 255a, so plus 250a. So which is the right option? It's very interesting question, this one also. Right. So A to the power of 4 value in terms of I and A, we need to express it. What is our answer? If A is equal to 1 0 1 2, then A to the power of 4 equals to. So now I will give the super shortcut for this one. So what is the super shortcut means? If A is a 2 by 2 matrix, 2 by 2 matrix, then the corresponding equation or characteristic equation is A square minus trace of A plus det of A into I equals to 0. 2 by 2 matrix means like this we need to find out. So first let us find out the characteristic equation corresponding to the matrix A. So let us find out now first of all. So right. So now what is the characteristic equation? Now write down all of you. First trace A, very simple, you can find out. A square minus trace. Trace means 2 plus 1 3, 3A plus determinant of this matrix 2 minus 1 0, 2I equals to 0. So this for our convenience, what do you write now here? So this A square is equal to, you can write A square is equal to 3A minus 2I, you can write. This is 3A minus 2I. So just if you observe A square is 3A minus 2I. So first let us find out one by one. So one by one. So multiply A square on both sides. Multiply A square on both sides. A square on both sides. Then what do we get? A power 4 equals to 3A cube minus 2A square, 2A square into I, A square only, 2A square you will get it. Clear? So now what should we do now here? Now you can write now. So A cube we need to write 1 minute. I will tell you one more logic, better to not multiplying. Okay. Squaring on both sides. This is a better way. Squaring on both sides means you get A to the power of 4 plus 3A minus 2I whole square. This is equal to, you get 9A square minus 2 3 is 6, 12AI means 12A plus this will be 4I square means 4I. This much you will get it. And next, my dear students, you remember one thing, again A square value, in the place of A square 3A minus 2I you can write. That is 9 of 3A minus 2I minus 12A plus 4I. Clear? So then what do we get now here? Right. Okay. This is actually, you can write 27A minus 18I, this is minus 12A plus 4I. So 27A minus 12A is 25A, this is minus 18 plus 4 minus 14I, you will get it, minus 14I. So this much we shall get it. So A to the power of 4 is equal to 15A minus 14I, you will get it now. So a to the power of 4, 25a minus 14i. So I need to change the option here. Better change this option now. Then here 1 minute. Okay, let us change B option. So that is B option is 25a minus 14i. So B is the right option. This is 255a plus 250a. So this B is the right option. Right, this is the 22nd question. Right, let us move to 23rd question now. 23rd question. Right, 23rd question. If A equals to 3175, right, such that a square plus xi equals to ya, then x plus y equals to. Generally these kind of questions may be asked in the examination as difficulty level questions. So first option is 8, sorry, option A is 8, option B is minus 8, option C is 6, option D is 0. So what is your answer? Very simple, by observation here. See, just concentrate on this one. A square plus xi plus ya is nothing but actually characteristic equation of this one. Find the characteristic equation of A and equate it to a square plus xi plus ya. You get xy value. After that add x and y value so that you will get the x plus y. So this is the process. So first let us write characteristic equation. So now the characteristic equation is a square minus trace of a into a plus det of a into I equals to 0. So now the characteristic equation will get a square trace of a 5 plus 3 is 8 minus 8a plus determinant of this matrix 15 minus 7 8i equals to 0. Now bring ya this side. So comparing with a square plus minus ya plus xi equals to 0. On comparison, x is equal to 8 and y is equal to minus 8. Now what we are asked? X plus y we are asked. So very simple to find out. So therefore x plus y equals to 8 minus 8. So answer is 0. So D is the right option. D is the right option. Okay, right. Okay, you might have got an idea, right? Okay, let us move to next question now. Next question, right? 24th question. Let us move to 24th question. 24th question. If A is equal to 1 0 0 0 1 0 AB minus 1, right, then A square equals to option A null matrix, null matrix. Option B is an unit matrix. So C, unit matrix means identity matrix only. Negative A, D is A means idempotent matrix only. So that means you need to find out A square value. So let us find out A square as you wish, your own way. Right. So A is given. Next, A square we need to find out. A square we need to find out. See, excuse me. First, trace of A find out. See, trace of A is equal to 1 plus 1 minus 1. Sum of the principal diagonal elements. Sum of the principal diagonal elements. So this will be 1 1 cancel 1. Next, sum of the cofactors of the principal diagonal elements. So that will be minus 1. Clear? This one, deleting this row, this column, deleting this row, this column. So minus 1. So this one is actually cofactor of this one is 1 plus 1. Again this will be minus 1. So next, det A. So det A, what is det A? So expanding first row, so that means here minus 1. Now the characteristic equation is characteristic equation is, we know the shortcut, A cube minus trace of A square plus sum of the cofactors of principal diagonal into A. So minus det A into I equals to 0. You need to remember this forever. Okay. So now the characteristic equation becomes A cube, trace A is 1. So minus A square. Now minus A minus 1 plus I equals to O. So from these two, let us take out A common. If you take A common, A square minus I. Here minus I common, you will get here A square minus I is equal to 0. So A square minus I into A minus I equals to 0. Two cases you will get. A square is equal to I and also A is equal to I. So A square is equal to I means involutory is not there. A is equal to I means unit matrix. So B is the right option. B is the right option. B is the right option. I hope you might have got this question now. Right? Okay, let us move to 25th question now. 25th question. 25th question. If 1 omega square are the cube roots of unity, then det of 1 omega to the power of n, omega to the power of 2n. See, omega to the power of n, omega to the power of 2n. Next 1 omega to the power of 2n and 1 omega to the power of n equals to. So that means determinant of this matrix is equal to. So what is the determinant of given matrix? Provided 1 omega square are the cube roots of unity. So option A 0, option B 1, option C omega, option D omega square. So this is the question. This is the question. See, 1 omega, omega square are the cube roots of unity. It's very important. That means, and next determinant of this one we need to find out. See, my dear students, here two cases will arise that we need to discuss here very clearly. Case 1. So what is the case 1 means? If n is a multiple of 3, n is a multiple of 3, n is a multiple of 3, omega to the power of n is 1, always remember like this. Obviously omega to the power of 2n also becomes 1. Case 2. So what is the case 2 means? We need to discuss. If n is not a multiple of 3, not a multiple of 3, not a multiple of 3 means omega to the power of n plus omega to the power of 2n is negative 1, or that implies 1 plus omega to the power of n plus omega to the power of 2n becomes always 0. So these two cases actually we need to discuss now. If case 1, what is the determinant? If case 2, what is the determinant? Two cases we need to discuss the determinants. So first case, case number 1. So provided if n is a multiple of 3, so that implies we know that omega to the power of n is equal to omega to the power of 2n is equal to 1. So then that becomes like this, 1 1 1 1 1 1 1 1 1. So if any two rows, any two columns are equal, determinant is 0. That's all. Go back to the case 2. So if n is not a multiple of 3, not a multiple of 3, not a multiple of 3, so that implies 1 plus omega to the power of n plus omega to the power of n is 0. So consider the determinants. What is the det actually? Here we have det of 1 omega to the power of n, omega to the power of 2n, omega to the power of 2n, omega to the power of n. Concept is very important, so we need to discuss. Though answer may be directly you can write omega to the power of 2n, n is equal to, you can substitute any value, even n is equal to 1 also you can substitute, no problem. So 1 omega to the power of 2n, so this is 1 and omega to the power of n. Here in order to find out this one, apply R1 is written, or C1 is written as C1 plus C2 plus C3. So that means add all the elements of the C1, C2, C3, write down in the first column. So we can write like this, 1 plus omega power n plus omega power 2n. This is 1 plus omega power n plus omega to the power 2n. So 1 plus omega power n plus omega power 2n. So omega power 2n, sorry n, omega power 2n and 1. This is omega power 2n, 1 and omega power n. So as n is not a multiple of 3, 1 plus omega to the power of n plus omega to the power of 2n is always 0. So that means first column becomes zeros, all the elements are zeros. So omega to the power of n, omega to the power of 2n and 1. Omega to the power of 2n, 1 1. If all the elements of any row or any column are zeros, the determinant becomes 0. So in both cases answer is 0. Go back. So answer is A. Option A is the right option. Or directly we can do, put n is equal to 1, 1 omega omega square like that. So if you apply C1 is written as C1 plus C2 plus C3. If 1 omega square or the cube root of unit C, you get two conditions. 1 plus omega square is always 0 and omega cube is equal to 1. So these two conditions will be satisfied if 1 omega are the cube roots of unity. I hope clear. So okay, tomorrow I shall continue the session because nobody is watching, nobody is interested. So thank you, bye bye. Let's see you.